afternoon, everyone. If you recall, we started this module with this table and specifically designing database with different levels, conceptual, with specifically on definition of entities and entity relationship in logical design with attributes and definition of primary keys, alternate keys, and specifically foreign keys. And a physical design, we went for designing table and changing the attributes into columns, and also defining some data type, okay? So you are starting with identify entity types, and also relationship between entities that you have, and also associate and any relationship between these entities would be important. Also identifying the candidate, primary and alternate key attributes, as well as the most important part of the story, which is checking for duplication and providing an efficient designing by considering and minimizing the redundancy and duplication, and also by some rules checking and obtaining the formal form at the end. So, and after that you will go for the physical design, a data dictionary, as well as creating tables and the story for the SQL. So these are just a quick review of what we have learned so far. We define entity, a distinct thing, independent existence about which we store data. We define entity as a logical things and not a specific thing. It can be a person, a place, a thing about which data can be stored. We also actually talk about relationships between entities. It can be one-to-one, can be one-to-n, or many-to-many. We can show by m colon n as well. Then, if you again recall, we define a group of attributes and as an entity, so in logical design, and in physical design, a number of columns actually defined as an entity. So this diagram actually shows the attributes in link with a specific entity, which we call entity relationship attributes diagram. And specifically here, because of some reason, we don't have any specific primary key, and we use 3 attributes as a composite key for this entity. We can have different type of attributes, such as derived attribute or multi-valued attributes, etc. So it's really important to consider this type of ER attribute diagram for your exam, for the class test, and also for the final. The story, actually, our story went to the problem and the issues that we had in link with duplication of data. When we are creating tables or creating forms, we face naturally with data duplication or data redundancy. If you again recall, we talk about some issues including the size of database. Specifically for large databases, this is really inefficient in terms of time and space. And most importantly, the issue of inaccuracy in our manipulation, including insertion, deletion, and updating. This duplication makes inefficiency in our design and decrease the referential integrity. So what was the solution? We said that we are going for a normalization step from unnormalized form to third normal form. So we're going to practice now the question that I gave you as a quiz. We are starting with a schema notation or unnormalized form schema or a form. This can be converted with a little bit changes to UNF, and then by applying some rule in 1NF, and then second normal form, and finally third normal form. So when you got the schema notation or a form, list all the attributes that you have, and specifically repeating groups would be in brackets, okay? So you have to identify a primary key or a chosen key for the whole attributes that you have. So it means you initially consider all the attributes just for one entity. So the rule that we are going to use for converting this UNF to first normal form would be this one. Okay, what is this? We're going to actually look at this list and then identify the repeated groups and then split these attributes into two different groups. And also we need to identify keys of each group and foreign key correspondingly by using @ okay? So this part is repeated for second and third normal form. Identify keys of each group and foreign key links using @ sign. Okay, so from UNF to first normal form, splitting attributes into two. So in this case, we will have technically two entities. Okay, so now we have the first normal form. The second, so we're going to see what is the rule by going from first normal form to second normal form. So the second one, we split the data, these attributes, into, again, different groups by focusing on part key dependencies. What does that mean? It means we're checking for non-key attributes dependency to every part of the primary key. Okay? So that's why we call part key dependency. So, and then again, for the new group, we're choosing the the keys and foreign key, and after that, again, using new rule to split the resulted form into new one. What is this rule? Here, again, we split any group based on this checking. What is the checking? Is checking of non-key dependency. We're checking for any non-key attributes which are not dependent on other non-key attributes. Okay? Every group at the end has to have a key and a foreign key linked with @ sign at the end. Okay? So this would be a summary of normalization step we mentioned. The first one is easy because you're using finding a repeated group and non-atomic attributes. The second, you're looking for a part key dependency. And for the third, you're looking for a non-key dependency. Okay, by considering this brief steps, we can go for this question. Okay, what is this question? The following is a form capturing stationary orders. First of all, you have to exactly read the question and understand the details of the attributes that we have. We have a form here, order number. This is stationary orders, order number, supplier company, supplier contact, supplier phone, requesting a staff number, and then requesting a staff name. What does that mean by requesting a staff? name and number, a person who requested this stationery, yeah, with this name and with this number, and authorized by someone else, another staff, can be a person who authorized this kind of order, okay? And authorized by name, this person, and order date is this date, okay? These are non-repeated group, and then we have a number of items which can be repeated. So item code, item description, quantity, unit, line total, pound, which is a multiplication of quantity per unit item, and order total, which is 970. Okay, so this part, this table actually illustrating the repeated part. You're given this unnormalized form schema, and then you're starting with this one. Or let's say order is the entity, the whole entity that we have at the first instance. Order number as a primary key for this entity or for this whole set. Supplier company, supplier contact, etc. till here, which is order date. And then this repeated group in the brackets, and also order total, which is not repeated technically. So the question was, you should write this out in table format, a list of attributes, one on each line with a blank line between entities. Note, if you want to represent something as underline, just write it as underscore and your word, okay? So this is the question. Right, okay, so we're gonna see what are the stages that to get the normalized form. UNF rule, the first one is list of unnormalized attributes showing the chosen key field and repeating groups. Okay, what would be the result? Order number as starting with underscore till here, item code, item description, quantity, and unit price. Okay, this is the easiest part, but you have to exclude two attributes, unit and the line total. And the reason is because these two attributes are derived attributes. Technically, you don't need to use these attributes as part of your entity. Why? Because the aim of normalization is minimizing redundancy or duplication. Okay, so next one. So now we have this one. I put it in a different order. So the next one, the rule is find a repeated group and non-atomic attributes, identify keys, including foreign keys with @. Okay, how can we separate this one? It's again, this part would be easier. So you separating these brackets from the rest of them. Yes. At the same time, you need to identify a primary key for this part, as well as a foreign key to link to the previous group. What about any atomic attribute? What do you think? So item code, item description, quantity, unit price, and order date, authorized by name, authorized by a staff number, requesting a staff number, supplier phone, supplier contact, and supplier company. Okay? So this is the first part, non-atomic attribute. A staff name as a requesting a staff the first name, requesting a staff surname. We can split, but still this would be acceptable for this part. Okay. So now we have two entities here, yes? Technically two tables. And these two tables, two entities, are linked through the order number as a foreign key linked with the first part. Okay. Now the second rule, the second normal for rule is find a part key dependency and identify again keys including foreign key with @. Okay. What does that mean, find a part key dependency? It means you are going to go for those non-key attributes group which have two primary key technically. So this one has just one primary key, so you easily ignore this part and you go for the second part because we have two primary key technically here, item code and order number. Okay, and then looking at non-key attributes, we have 1, 2, 3 non-key attributes. Okay, so item description dependent on item code, but item description, is it dependent on order number? No. Item description is just dependent on item code. It means we have part key dependency. Okay? So if this one actually dependent on both parts, we wouldn't actually split this. But in this case, because item descriptions is just dependent on item code and not this one, is we have a part key dependency. In that case, we have to split these two parts, item code and description, item description and unit price. So, and you can imagine, I mean, because we are going to reduce the redundancy, this is technically different from this part, because this can be in general in link with any type of ordering, but this one, item code and quantity, is linked to just the order number entity. So in this case, we split this group into two parts, item code, item description and unit price, and quantity, and quantity technically would be a part of order number. At the same time, we need to have item code as a foreign key linked with the second group. Yeah? Any question? So we are going for next rule, which says that find a non-key dependency. Okay, what does that mean? It means we are again looking at non-key attributes, something like this one, and checking for any dependency on other non-key attributes. So another part of the module we focused on data set and data mining as well. Very quick review on this part. We mentioned the three main sources of data with e-commerce platform, pharmaceutical industry and medicine, and also social media. And we mentioned that all of this data usually has the difficulty of the problem of organizing all of this data, and by different type of data analytics, data mining, as well as database design, we organizing all of this data. In data mining and analysis, which is by itself is another module, we have these four stages: data collection and assembly. You usually starting with gathering all of the data. It could be something like survey, questionnaire. It could be any kind of data entry through the social media. All of this providing data. The second part for data mining is data pre-processing. It means you have let's say a just simple table or Excel file, a spreadsheet file with loads of features or attributes with different samples. The first step is cleaning and transforming this data, or maybe integrating this data. Sometimes you need to address the missingness. You have to harmonize the name in a consistent way, having the same attributes, etc. The second part is data pre-processing. The next step, which is the main, is data modeling or model development or data mining, finding any rules from the data that we have. And usually actually with the help of interpretation and visualization, we will achieve loads of discoveries in different fields and finding patterns in our data set. So this was an example of a data set in the UK with in 4 countries, and these are all features or attributes, and also in 4 countries. And by just looking at the numbers, the food consumption based on this information here, we realize that 1, 2, 3, 4, 5 features or 5 attributes can help us to group or cluster or differentiate these 4 countries. So for instance, we realize that in Northern Ireland, the consumption of fresh potatoes compared to other countries in the UK are larger than other countries. For instance, for fresh fruit, perhaps they don't like fresh fruit, 674 compared to 1,900, 1,000 in other countries, etc. So by looking at these numbers, we can identify some patterns or some rules in which this actually allows us to differentiate these or cluster or group these 4 countries. But in data mining and data analytics or machine learning, all this stuff, we are writing some code, some scripts in which actually automatically identify all of these patterns and rules. So another example was this data set which was collected from a cricket player, and by this kind of features: outlook, temperature, humidity, windy, and play. If there was a play in different weather situation, and the aim was identifying any rule or any patterns in this data set. And by looking at all of this data, we realized that, for instance, if humidity is normal and is not windy, it means windy situation is false. So there would be some play for this game. So these are some examples of patterns and rules. Another one, if the temperature is cool, then humidity is normal. So, and for this case, as you realize, for instance, we have, let's see, normal, false, and this one cool and normal. Yeah, I mean, these are a small number of data, okay, a small number of rows that we have. Sometimes we have, let's say, thousands of data, and we are always actually looking at the majority of agreement, majority of cases which satisfy a specific rule. It's not 100% maybe correct that in a cool temperature we have humidity normal. Maybe in a cool situation, when you gather more information, more data, you will face with some cases that the temperature was actually cool, but the humidity is not normal. So there would be some, in a large population of data collection, maybe we will face with the exception cases as well. But all of this as part of data mining and data analytics. Okay, and thank you for your attention, and hope you enjoy my lecture. Thank you.